Hi, this instructional video is a dilation, but this time we're going to dilate a negative dilation, which is reduction. Reduction. We're going to make it smaller. Let me move the camera a little bit here. There we go. And this time, what I'm going to do is I'm going to draw some random polygon on this coordinate plane. For example, right here, let's choose this one, this one, this one, and this one. I have no idea what these coordinates are. I just randomly chose them. And it looks like it appears to be a trapezoid. By the way, a little trivia question. How do you define a trapezoid? A trapezoid must have one pair, at least of one pair of lines that are parallel to each other. And I think this is it, I'm not sure. So anyway, we're going to dilate this. Dilate by factor of 1/3. Dig that one, huh? 1/3. So it's going to be 1/3 the size. So the previous video, we dilated by a factor of 2. And since it's a whole number, it got bigger. Double the size, in fact. But now it's a fraction. It's fraction of the original, so it's smaller. How much smaller? 1/3 of whatever it was originally. How do we do this? So just like before, let's call this one A, B, C, D. And we're going to mark out the new A prime, B prime, C prime, D prime, and it should be smaller. So let's start by drawing a line through the origin, from the origin through the A. And this time, instead of enlarging going out, we're going to go inward. We're going to go inward. We're going to need to move that a little bit more, don't we? There we go. So we're going to move inward this time because we're going to get smaller. So here we have the distance right here, whatever this is. Now, this is a little difficult. If I had a ruler, like right here, and if I were to measure it, this almost looks like, what does that say? It's almost 1, 2, 3, 4. Almost 1, 2, 3, 4. But we have to measure, break this up into thirds because it's 1/3. So what's 4 divided by 3? What is that? It's about 1.33333. So less than 1/2. So it's going to be about 1.3 around here. And you know what? I'm going to eyeball it. Here's 1. Here's 2. And here's, ta-da, 3. So it's 1/3. So if this is A, this is going to be A prime. And I'm going to do the same thing with this B here. I'm going to draw the line from the origin to the vertex B. And now I'm going to break this distance into thirds. I'm going to estimate it like here's there. That looks pretty close, doesn't it? 1/3, 2/3, and 3/3. So this will be B prime. Are you seeing this? Now the C, I'm going to go from the origin all the way to the C. And I'm going to break this. Oh, you know what? With all this line here, I'm kind of getting confused. What is what? So I'm going to use this here. Here's the origin. Here's a C. So I'm going to say that's about 1/3, 2/3, 3/3. Does that look right? Kind of? Yeah? Right there. So 1/3, 2/3, 3/3. So this will be the C prime now. And finally the D. D is over here. So I'm going to break that up into thirds also. So here's origin to the D. And if I break this up into thirds, it'll look something like this. Look at that. I'm pretty good, actually. So here's 1/3, here's 2/3. So this will be D prime. Now here's the big one. Here's the original trapezoidal looking thing. Now if I connect the lines, connect the vertices together, I should have a little miniature version of this trapezoidal thing that I just had. There it is. You see that right there? That now becomes 1/3 of the original. I went backwards. Crazy stuff, huh? Yeah.